My name is Charlie Day. I am the training lead for DesignSafe. I'm also the director of training and professional development here at TACC. And I'd like to introduce you guys to TACC a little bit first, then talk a little bit about where to get help in the community that DesignSafe is trying to build. And then we'll go on with our guest lecturer, our guest presenter. Thank you very much for coming today. I hope you guys hope this is informative. So first off, well, I'd like to also welcome you guys to TACC. So TACC, we are the Texas Advanced Computing Center. We are a supercomputing center located in Austin, Texas as part of the University of Texas. We have approximately 160 people on staff, about 70 PhDs, usually about 20 students or so. And we are mostly funded by the National Science Foundation and the UT Systems, and we have other grants as well, such as DesignSafe. What TACC provides is the underlying infrastructure to DesignSafe, how DesignSafe works. We have basically all the computational power and all the cloud computing power that DesignSafe requires. So what we do about 1 billion compute hours per year, approximately 5 billion files and 50 petabytes of data stored at our systems here. We have hundreds of public data sets, and we have a giant 10 megawatt data center as well. The systems and services we provide are all HPC computing resources. We do high throughput computing, large scale data storage that is required for a system as DesignSafe. Cloud computing, visualization, we do data analysis, we do machine learning. We also write portals and gateways. So a portal is like DesignSafe. DesignSafe is a portal to our supercomputers in the background. So each time you're actually running a job, what you're really doing is executing a job on our supercomputer. And we also do consulting and data curation. We'll talk a little bit about data curation and what kind of services we can offer the DesignSafe community. We do code optimization, we do training and outreach, and run webinars like today. We have about 15 to 20 different HPC resources. Our #1 resource is a machine called Stampede 2. We'll talk about that a little bit more. But the other major resource I wanted to point out is Corral. So Corral is our, you can count that as our big file system, our big file storage. All of DesignSafe files, all of your data resides on Corral. So Corral is 11 petabytes and is replicated between here in Austin and up at UT Arlington. You get about 5 terabytes free to all UT system principal investigators. After that, there's a nominal fee for some cost recovery. But essentially what we do is we do project data sharing and collection hosting on this machine. So that's why we have opened this up to DesignSafe. All of your data that you are creating, all of your data that you are generating is being stored on Corral. So our big flagship machine is Stampede 2. Stampede 2 is part of the Strategic National Reserve. We have thousands of researchers across the nation and across the country, across the world, using our system. We have, it's approximately 18 petaflops of peak performance. There are 4,200 Intel Knights landing nodes. Each of those nodes have 68 cores and 96 gigabytes of RAM and 16 gigabytes of high-speed RAM. We also have about 1,700 Intel Xeon Skylake nodes. These are probably the state-of-the-art nodes currently that Intel makes, the Skylake CPUs. Each one has 48 cores and about 192 gigabytes of memory. Then we have also 100 gigabytes per second Intel Omnipath network that kind of wraps everything together. So there's basically trying to cut down the lag between the different nodes that you can pick for your doing parallel processing. We also have 2 dedicated Lustre file systems, and we have about 31 petabytes there. And of course, this gives you access to our global shared file system that was mentioned earlier. All right, so everybody who signs up for DesignSafe gets a base allocation. All right, so as part of DesignSafe, you have a base allocation of about 8,000 service units and about 50 gigabytes of storage. This is outside of DesignSafe. So you as a DesignSafe user, you have these things available to you. All you really need to do is email us here at TACC, and we can get that going for you. This is roughly equivalent to a use of a single processor core for 1 year. So who's eligible who's eligible as a PI? So additional allocations on DesignSafe is headed by the project PI. You can be an NSF graduate student research fellow, research staff employed by one of the many federal agencies. You can do state educational offices or organizations. This includes K through 12. Museums, observatories, libraries, other research labs. They're all welcome to become a principal investigator on a project for our systems. So this is a little bit about information on how you're actually charged. So compute time is allocated in service units. Like I said, each allocation gets about 8,000 service units as a startup. That's what you have. Then we have compute time is charged on the computations run through the Discovery workspace, through the web interface, or through direct command line access, or through Jupyter Notebooks. Storage is allocated and charged gigabyte per year. Physical storage on 1 year per sitting on our machines. If you need additional allocations, please feel free to fill out a help ticket and include the information and the eligibility of the requester, description of the research you would like to perform, how your research is being supported, and then a justification for how many service units you're going to require. These are as a breakdown of the different levels of allocations that we have. We have base allocation, we have the startup allocation, research allocation, educational allocation, and what those exactly mean. You can also find this on TACC's website. And then approximately sizes and limits and what the cost for those sizes and limits are. And these are the review criteria that we use here at TACC to, when we give additional allocations on proposals. We're looking at the scientific merit, what the methodology is going to be used of the DesignSafe resources, success of prior allocations or research that you've done, what kind of use of other NHERI funded facilities you're using, and funding support for the project outside of the NSF or other grants with the NSF. So with that, I'd like to tell you a little bit about DesignSafe's vision. All right, so I've been with DesignSafe since we first fired it up here at TACC. And what our entire goal was with DesignSafe is to build a cyber infrastructure that's going to become an integral and dynamic part of your research lifecycle. All right, everything from when you first conceptualize the research project you're going to do, to actually executing the project, to actually getting data out of the project, and then, of course, starting that life cycle again. We're doing this through providing a bunch of cloud-based tools, cloud-based tools that support the analysis, support your visualization, integrating different types of data. We understand that we're looking at, there's lots of researchers who are using this system, and we want to make sure that our data types and our data management is flexible to integrate in your structure. We want to, like I said, we want to support the end-to-end research cycle from conception all the way to research that leads back to conception. And we would like to enhance and amplify all the capabilities of the NHERI components and bring it into DesignSafe. So the way it works is DesignSafe is broken up into 3 different research areas, and then DesignSafe brings that information into our data depot and then our discovery workspace to do all the analysis. So we have simulation research, we have the experimental research, and then we have the rapid research, right, with the reconnaissance portal. And the idea is all these different researchers are creating data. That data is being stored on our data depot. From the data depot, we can then do data analysis and visualization, and then create new sets of data. And then when your data is ready to be published, you'll be able to curate that data and publish that data directly from the Red Data Depot and directly through DesignSafe. So in order to build a community, we have built up that community around Slack as our communication tool. Slack is actually a communication tool, but it's a little bit more than just that. Slack is built into Teams. Our team is the DesignSafe team. If you haven't got an invitation to DesignSafe yet, to the DesignSafe Slack team, send us a help ticket and we'll get that over to you. The Slack is split into channels. Each channel is essentially a topic of discussion. Anyone can create a channel. You can invite any other TACC or any other DesignSafe user to those channels. You can have private conversations. You can break things into threads. You can then search on these conversations. You can do highlights, and you can look for keywords. So when those keywords come up in conversations, it'll send you an alert so you can actually go in and review that. During the hurricane season, a lot of the hurricane reconnaissance researchers use Slack as a method of communication between teams and where they're putting their equipment at and what kind of equipment they're using and the sharing selfies and all that stuff. It's actually a really great tool and it's become quite useful to DesignSafe. You can also do fun stuff. You can set up reminders, you can start messages, you can do team-wide searches, and of course you can play with animated GIFs. So feel free to find us at DesignSafe-CI.slack.com. So if you ever get lost using DesignSafe, there's the help menu. Going to the help menu, that's where the frequently asked questions are, that's where our user guides are, that's where we have our getting started videos, and that's where you can submit a ticket to get additional allocations, for example, or to get yourself hooked up to Globus, to get your data into DesignSafe. All right, so speaking of data, your data tells a story, and we understand that the purpose of your data is to get that story out to the rest of the community. So we have a philosophy behind our data curation. Our vision is to allow users to easily store, share, document, and publish their data throughout the entire life cycle of your project. So as I mentioned earlier, our goal was to make the data model very flexible and very interactive and make the creation process very interactive, allowing researchers to decide how they want their data to be represented and not give you such a strict model that you have to represent it our way. So for that purpose, the data depot, you'll notice, looks very similar to a file manager where files and folders are kept to organize your data. But because of that, we've given you a method of curating your data to give your data categories and define what those categories are. So you can start your data creation process through defining a category tree of how is your data related to each other. You have a model, you have sensors, you have events. So this is one example. We have a model configuration, we have a sensor, and then we have an event that goes with that sensor, that goes with that model. And you store all that information in there. And then you take that category and you assign that to your different data files. So now you have these data files that relate to these categories that you've created. And now it becomes part of that category tree. So the idea is define your category tree, assign categories to your files, and then publish those projects. And when everything's been curated, you publish your project and you publish your file. So essentially what it does is we now have a data model that's flexible, that can be applied to different types of research being done, experimental, simulation, hybrid, or reconnaissance. And to help you through this process, if you go to DesignSafe, you'll notice that we have a data curator, a data creation scientist on our staff. Her name is Dr. Maria Esteva. Maria is incredible, and I highly recommend that if you have any questions regarding data curation, you go into her office hour Zoom meetings that she has on Tuesdays and Thursdays, and she'll be more than happy to walk you through the data creation process. So there's various ways of getting your data into DesignSafe. Once you get your data into DesignSafe, you can use DesignSafe to do all of your data analysis and all of your visualization and all of your modeling. But if you have existing data, these are the ways to get it into here. You can use the data depot or upload through a Jupyter Notebook. Those are small number of files, less than 25 files, less than 100 megabytes. Or you can use some cloud resources. We have Box.com, Dropbox, Google Drive. You can then copy your folders into the cloud resource and then copy them over to DesignSafe. There's also Globus. Globus is probably the best way of getting a large number of files and a large size of files into DesignSafe. There is some documentation available on DesignSafe. There's also a webinar we did on how to use Globus, which I suggest you checking out. That will essentially walk you through the entire process of getting your data, large amounts of data, into DesignSafe through Globus. We also have command line. We have a command line interface as well. If you're comfortable using command line, you can use rsync and scp to get your data into DesignSafe as well. And these are the links for the data transfer guide and the Globus data transfer guide. That will give you some more information. So essentially what we want is we want to make your data count, all right? Your data is worth a lot. You've done a lot of hard work to get that data, to get to that data. And like I said, it tells a story. So what we'd love you to do is be able to use DesignSafe as a medium to get that story out. And you can formally publish your data sets, like I mentioned. This is everything that has to do with your data. That means it's your processing scripts, your visualizations, your CSV files, your JSON files, everything that has to do with your data set can be published in our repos on DesignSafe. It's backed up, it's stable, and it's a very clean way of having your data whenever you need it. Your data gets a permanent location and a DOI. So a DOI allows the person to link back to the original location of the data. All right, it's not just a URL, it is a digital location, it's a digital identifier to your data that people can then use to cite. And once, of course, they cite your data, they can create, it goes into your reference list for your papers, and you can see who's using your data, how your data is being used, and what other data sets have been created from your data that you've originally published. So with that, I'm going to go ahead and hand this over to Margot. Let me tell you a little bit about her. So Margot is, she is a postdoctoral fellow here at the University of Texas at Austin. She originally got her bachelor's degree and master's degree in civil engineering in Italy, and she obtained her PhD from the University of Naples. She spent 2 years as a postdoctoral research fellow at UCLA, and now she's come here to UT Austin, and we are actually extremely lucky to have her and using her talents quite extensively on expanding the capabilities of DesignSafe. So with that, she's going to walk you through using DesignSafe and using OpenSees, everything from data analysis all the way to data publication. So with that, Margot, I'm sure you're on the line. I'm going to go ahead and stop my share and then hand this over to you. Thank you so much, and hope you enjoy the presentation. If you have any questions, once again, jump on the Zoom chat, and one of us here at TACC or on DesignSafe will be able to answer your questions. Thank you very much.
Hi, everyone. Hi, Charlie. Thank you for the introduction. I will go ahead and share my screen.
You might still be muted, Margot.
Oh. Can you hear me?
Yes, we can hear you, Margot.
Okay.
Go ahead.
Okay, perfect. Okay. Hello, everyone. As we were saying, I will walk through.
Hey, Margot, I'm still unable to hear you.
Oh.
I'm not sure if I'm the only one or not.
We can hear you okay.
Oh, okay.
Yep, now you're good. Thanks, Margot.
Okay, okay, perfect. Okay, hello everyone again. So I will introduce you to OpenSees and how to use it in particular in OpenSees. And my presentation will start, sorry, I think that. There was an issue with my presentation. Sorry for that. There is something going on with my presentation. Okay, here we are. Sorry for that. So let's start with some introduction. During this presentation, I will assume a basic knowledge of OpenSees and how it works and how to construct a basic TACC file. So that's something necessary to go through the DesignSafe opportunity and capability that you will have here. So First of all, let's start with some introduction with the outline of my presentation. I will start with some description of what are the OpenSees applications available on OpenSees. Then we'll go through on how to launch those applications. We'll show you some alternative to how to post-processing data after your analysis has completed, and then some alternative ways to launch OpenSees. So let's start with the application available on DesignSafe. First of all, you all know that when you are first getting to DesignSafe, you have to go to the research workbench and click on the workspace. Here you will have a look to all the applications that are currently available on DesignSafe through the simulation tab. As you can see, we have a bunch of different applications, but in this presentation, we will just focus on OpenSees. In particular, as you can see here, we have 5 different applications, and I will explain you what each application does and why we have different versions of them. In particular, we can see that we have something that we call OpenSees EXPRESS, that is basically the basic sequential interpreter for OpenSees that I'm sure that all of you already used in the research. And then we have 2 different versions, that is OpenSees MP. We have version 2.5 and version 3, and then we have also OpenSees SP version 2.5 and 3 as well. And those 2 applications are different from the previous one because are taking advantage of parallel computation. So let's start with in more details what those applications are able to do. First of all, OpenSees, as I was mentioning, is a sequential interpreter. So it means that basically you are running, you have pros and cons using those applications. The main pros when you are using this application on DesignSafe is that it runs on a virtual machine, free your own machine, and you can use that for doing your own work. The other very good thing of using OpenSees, the sequential interpreter on DesignSafe, is that you don't need to wait for the queue. Since you are using a virtual machine, your analysis will start just in a few minutes, so you don't need to wait for other jobs. The main cons is that it's not ideal, of course, for very large models because the computational time will be too high and is not worth it to do that for your analysis. Then we have let's see what are the parallel version interpreters available on DesignSafe. First of all, we have, of course, OpenSees SP that is specifically developed for high performance computers. And the main pros of this is that this interpreter is ideal for very large models. And another important thing is that you have to just make some minor changes to the script. It means that it's very handy and you can easily use and take advantage of high performance computing in your analysis. The cons is that in this case, we are using high computer. In particular, we are using through the portal Stampede2 that Charlie was mentioning before, and it goes into the queue. It means that you have to wait for your turn before that your analysis will actually start on the computer. The other parallel version available is OpenSees MP, and in this case we have the main pros is that it's ideal not only for very large model but also for parametric studies. In particular, this is voted to the analysis of parametric studies. And in this case, you have more control on the parallelization process. This means also that, of course, you need to have more knowledge about how the parallelization works. And also you need to build additional TCL script to launch the analysis. And of course, also this one, it will go directly into the queue. So you have to wait for your turn before the actual analysis is starting. So now let's see a bit more in details how those 2 parallel interpreters work. So let's start with OpenSees SP. SP stands for Single Parallel Interpreter. And the point is that basically we have a main processor that we'll call P0 that is reading the script, and it's able to build the model and to check what are the analysis, the properties of the analysis. And then after doing that, basically it just sends part of the subdomain to the different processors. So in this way, we will have the main processor that is studying what is the problem, and then you have to just submit, it will submit the analysis to other component of the process. that will run subdomain model, and then everything will be reconstructed. When you are using this type of processor, you need to modify your script, as I was mentioning before, and the minimum changes to the script include the change of the equation of the solver, so what we call in a TACC script system command, and you have to pick one of those two that will allow the division of the domain in the subdomain for the subsequent analysis. And then you have to change the output command for the record, substituting the file flag that we usually use for the standard TACC file with the XML flag in order to have an ordinate output. The difference with OpenSees MP, basically when we are running OpenSees MP, if you want to run a very large model, it works exactly like OpenSees SP. So you have a subdomain division. But it works differently if you want to run some parametric analysis. In particular, for parametric analysis, the interpreter runs in parallel several slightly different versions of the basic OpenSees interpreter. Let's call it like the sequential one. And each of them basically runs an independent analysis. And what you can obtain from this interpreter is like the total number of processors that we'll call MP that you need for forming the parallel analysis, and the processor ID number that is a unique number. So basically what it happens that each analysis is able to, its processor is able to run a full complete analysis. How you have to modify the script? Again, for large model, you have to change the basic TACC script, and you have to change how the degrees of freedom are numbered, so changing the number command and pick one of those two. And you have also to change the system equation at the solver again, and this time, as you can see, compared to the case of OpenSees SP, you have in addition another system that you can pick for this interpreter. But I was mentioning something very useful for using OpenSees MP is to use this tool for running parametric studies. In this case, as I was mentioning, you need an additional script. So now I will show you how this script looks like and what each command, the main command, are constructed in your analysis. First of all, we have to set up to obtain the processor ID of each machine that we are using, and the total number of processors available. And that's something that we need in order to divide the analysis among the whole available cores. Then we are talking about a parametric study. So of course we need to have a variable list, something that where we are storing all the variables that we want to change during our job, in our parametric studies. And when we define that, we will start counting, we will initiate a count in order to split the analysis among the different applications. And this will allow basically you to have each analysis run just one time. And then with those two commands, you basically, you create a loop that goes through all the variables available. We read how many analyses you need to run in total, and we'll split each analysis to the first available processors. So that's the script that you need that is actually splitting the analysis among your interpreter, the different interpreters, and so to the different processors that you have. After doing that, you just need to select one value from the variable list and assign this value to the variable that you want in your script. At this point, you need to call a sequential script, a script that is basically almost the same that you already had for the sequential analysis. And the only difference is that, of course, the variable that you want to change needs to be defined outside the script in order to change each time that you are running through the loop. So after doing that, the code will be able just to go through all the variables until you run all the analysis that you needed. So at this point, before going to the actual example, because we will run through an actual example, I want to put your attention on something that is gonna change on the portal. because there is always some update and some work behind this portal. And in particular, it's coming soon a new interface that will affect how you can pick your application from the portal. And in particular, the simulation tab will be different. And in this case, will be very handy just to select the type of application ahead. So in this case, as you can see here, you can select just the OpenSees. You will have one tab for each application available. In particular, for if you click on OpenSees, you will find before a small description of what OpenSees is and what it's able to do, and then what are the interpreters are available on the portal, with a brief description of which one you have to pick if you are not familiar with the portal, and also with the name of the different interpreters. So, and after that, you can select the desired application from a drop-down menu. And in particular, once you will select a specific application that you need for your analysis, you will find a small description that will just underline what I was just telling you. So basically that OpenSees Express is the sequential version, and then you have the SP, that is a parallel version that is ideal for very large model, and also the MP that is ideal for parallel for parametric analysis. In this case, we have also some details of the number of nodes and how to select some preferences from this tab for submitting the job. So at this point, let's go through the second step of this presentation, and let's see how to launch an OpenSees application. Before going through them, I just want to mention to you that everything that you will see starting from this point in terms of TACC scripts and post-processing file and everything else will be available on the community data for you for downloading, use, modify, and do and use as a start for your future work on DesignSafe. So of course we need an example for running the analysis, and I decided to use the effective site response analysis example. This is a well-known example, very well documented, that is already present on the OpenSees main page in the geotechnical example, and it's a basic geotechnical example about the effective stress site response analysis of a layered deposit. And we are considering elastic half space. The model we are considering is one column that is modeled in 2D. We have that is subjected to earthquake excitation. We are using 9 quad elements that are able to monitor the stress and also the pore pressure to model the effective stress variation during the motion. And then we are using Leismer-Kuhlmeier dashpot at the base to simulate the elastic half space. We will use this example as a base, and then we will run 2 different examples. The first one will be just the sequential version of this, so just the problem as it is using the ground motion provided in the example from the OpenSees web page, and then we will use a modified version of it, basically using the OpenSees MP capabilities, and in particular we use 3 different input motion for running our small parametric analysis. First of all, before everything, you need to know how to upload data. Charlie was already mentioning this to you, but I just want briefly to underline that you just need to go through the workbench, data depot, and then you will be in your personal space where you have all your data, and you can easily add data using file or folder upload and do whatever you want and managing your file. This point, let's start with the example for OpenSees Express. As I was mentioning a few minutes ago, you just need to go to the workspace and pick in the configuration as it is now the OpenSees Express tab directly from the simulation tab. And then you will have the drop-down menu. So that's what the screen will look like to you. Basically, you can see that you have basically 2 different sections in your analysis in the form for submitting the analysis. There is an input section that is on the top part, and then there are some job details. For the inputs, you just need to tell the system what is the input directory, and you can do that in 2 different ways. One is just typing here what is the path and the folder that you are referring to, starting from my data, so from the main folder, or you can just select the input from this data depot browser that is on the left of the screen. Then you need as an input to put what is the name of the TACC script, that is the main file that you want to run, and then there are some details about the job. Sorry, and then you have to define what is the maximum job runtime and the job name. In particular, the maximum job runtime is something very important because the system will just close and quit your analysis once you will reach this time. So it's very important to calibrate it to accommodate the time of your running. The job name is also very important because it will be the identifier of your analysis, and you will use it throughout your post-processing data as well. And then you have the alternative, you have the possibility to select what is the job output location. That is something optional that will just, and you can do it exactly in the same way as you were doing for the input directory. Once you fill in all the information, as you can see here, everything will change the color, in particular if there is no error in the way you were typing the input and everything looks good to the system, everything will turn green. And then once you are ready and you put all the information, in particular, I just want to underline that the job name that we are using for this analysis is OpenSees EXPRESS. And then you can run your analysis. And then you will see a small tab that is submitting your job, and you will see something like that after that. Starting from this point, you can start monitoring the status of your job from this window on the right of the screen, in which there are all the different phases of your analysis. In particular, you will see changing this during your analysis. And once it's finished, you will have you can access the data in the output. In particular, if you click on the more information button, you will see something like that, and where you can check what is the application. First of all, at the top, you will see the name that you were assigning to the job, what is the application that you were using, what is the status, and then the time when it started and when we finished it. After that, you can click, you have something very useful that is a direct link to the output that you can have clicking on the view button, and that will guide you directly will bring you to the folder with all the output, sorry. So what is present in this output folder? Of course, you will have several files that are related just to how the analysis was managed by the portal, and then you will have your folder with all the actual results from your analysis. Something very interesting to take a look at is the OpenSees Express, that's the name of the file, .r. This file is very important because we will show you basically what was happening during the analysis on the actual interpreter level. So you can see here something that you're all very familiar with, that is the classical OpenSees screen and all the commands that are related to your code. So what is the size and everything you were asking for to put on screen during your analysis. The output, the folder with the name that has the name of the job will contain then all the output of your analysis, and in particular, it will also have all the input files. As you can see here, this free field effective.tcl file was exactly the input file that we were considering. So basically in this folder, you will find output plus the input. So as it happens on your personal computer when you are running locally your analysis. At this point, let's see how it works when we want to run on OpenSees MP, because until this point everything was familiar, was very handy, and was exactly what was shown on the OpenSees website. There is some difference when you want to run OpenSees MP. First of all, I want to underline that you need some, as we were mentioning before, some additional files. In particular, you need to have the list of variables that I was mentioning before and the additional TACC file. So in this particular case, I was storing all the input instead of having one file reading them, since in this case we are talking about ground motion. We have all the ground motions in one folder that is in the same input directory that we are working on. And in this case, we are using ground motion that are from the peer database. So they are, you can just, using this code, you can just grab the ground motion from the peer database and use them directly, because the code will be able to convert them in the correct format for the OpenSees analysis. The additional TACC file is what we call here parallel motion. And in this case, as you can see here, looks similar to what we were looking at before in the example file, but is of course a bit more complicated. In particular, as you can see, the most important thing is that we are still, we are looking, of course, what is available as a resources in our system, and then we source the record TACC. This file is, you just need this file to convert the script, as I was mentioning, from the peer database to the format that you will need for the OpenSees analysis. And all the variables basically are contained in this, as you can see here with this loop. The system is able to reconnect, to read all the file of input motion present in the ground motion in the GM folder. After doing that, after defining few variables like the velocity file, that is what you need for running the analysis on OpenSees, and after setting up the time step for the ground motion and the number of steps that is of course variable for each ground motion, you can just source the sequential TACC file. I just want to underline again that of course you have to change these, slightly change this TACC file in order to have those variables that we are defining here outside the TACC, outside those sequential file in the file before calling the actual file. And after that, we can just go through, the system will go through the loop and read how many input we have and just run all of them. At this point, let's see how the system looks like when we are running the analysis. So for OpenSees MP, we can see that the form that we have to fill to submit the job is very similar to what we were looking at before for OpenSees Express. So we have still the input section and then the job details, but we can notice that in the job details there is one more information that we need to add, that is the information about the node count. Now, this is something that we need, of course, because as I was mentioning, this is a parallel interpreter. So we need to use some parallel computation, and we need to access and to ask for the use of the Stampede 2. In particular, we deal with that asking for a number of count. The number of count defines the number of processors that we need, and using the portal, each node assigns to the job 64 cores. So automatically, when you will ask for one node, you will have 64 processors that are able to run in parallel. In particular, using the portal, you can ask up to 12 nodes. So 12 times 64 cores you will have in total. In this case, so once you fill the form, you will see again everything will look similar to that. Again, it's very important what is the maximum job runtime, and in this case you have to know that basically you are asking, this time is the time that you are asking for each core that you are using. So you need to take to consider that when you are asking for a parallel analysis, you should know exactly how many, what is the time to run that you are asking for each core. Once you select all of these, in this case, I want to underline the name of the job is OpenSees MP. You can just submit your analysis, and you will see again something very similar to what we saw before. Once the analysis is completed, you can again see at all the details. You have the application that you are using, the version of the interpreter, what is the status and the initial and the finishing time, and then you can take a look to the output just clicking to this link. In the output, the general output, as you can see here, is just the same files that we were looking at before. So the interesting thing is that, of course, this time the .r file will look different. And in particular here is a small video, a short video that will show you how it looks like. As you can see here, we have more information than before actually running the analysis, and then we will open the interpreter. Something that I want to underline here is that basically when you are running a parallel analysis, you're asking the system on DesignSafe is assigning you automatically 64 cores. In this case, we were running a parametric analysis with just 3 ground motions. It means that we have a bunch of different processors, in particular 61, that we are not going to use because we just need 3 for our standard analysis. So you can see that the system automatically will terminate at 61 processors, and then we'll run the analysis just for using the 3 cores that it actually need. As you can see here, we run the 3 ground motion that we were, the system found in the GM directory. At this point in the OpenSees MP folder, you can see that there are also all the results that, of course, I changed in the TACC file, how the recorded were, the tag for the recorder in order to have also the name of the ground motion that they were referring to. So you don't need to have subfolders. You can have directly the input, all the input in the same directory. At this point, once that we have all the analysis results from the OpenSees EXPRESS and also from OpenSees MP, we can just take a look to all the different post-processing alternatives. First of all, we have, if we want to work on the cloud, we can use the tools that are already available on DesignSafe under the data processing tab. In particular, you can use Jupyter Notebook or Matlab. Or it's always present the alternative to download all the outputs and post-process data locally. That's up to you if you have a specific code that you want to use for your post-processing data that is not available on DesignSafe, or even if you are more confident with this. But let's start with what you can do on the cloud, because this is the point of using DesignSafe. Let's start with Jupyter Notebook. Of course, you can find Jupyter Notebook on the data processing tab. You just need to click on it, and you will have a window in which that you can just launch your Jupyter Notebook, and it will look something like that. So as I was already mentioning before, all those data will be available, and all the script and all the data will be available in a community data. Here in red, there is the link to those files. In particular, all the TACC file are in the folder, and also the output everything is in the folder, OpenSees EXPRESS and OpenSees MP, while we will provide also some post-processing Jupyter Notebook for both the Express version and also the MP analysis, and those are in the main folder, OpenSees. So let's see how this post-processing file looks like. So basically, once you click on this file, you will have the script that it's available that you can also modify. You can run it, and then you will see that after it takes just few seconds, because it's also simple analysis. You can see what is the output, and we were also taking out some outputs from this analysis. In particular, we are plotting acceleration time series at surface and at base, and something very useful is the interactive figures that you can basically go on, zoom in, zoom out, check the points interactively, the location of the points interactively, and also save directly on your local space the different figures. Then we have surface acceleration and log spectra for the surface acceleration. We have output about the maximum profile displacement and PGA, shear strain, and tau over sigma vertical stress along that. And then we have, for the location of maximum shear strain, the stress strain response and also the pore pressure at that specific depth. This is just one example, just to give you an idea of what are the capability, the Jupyter capability, but of course you can create your own code and have everything, manage the data as much as you want. Similarly to that, I was mentioning we provide also a notebook for the post-processing of the parallel analysis. In this case, you will just see all the data on the same plot, so just to compare the results related to the different ground motion, and the output provided are exactly the same. As I was mentioning, we can also use Matlab instead of Jupyter, that is also available. But the difference is that since Matlab is not an open source code, you have to submit a ticket to activate your license on DesignSafe. So you just need to ask for that, and tell the TACC team why you want to use that, and you will have Matlab activated on your computer. We have two different versions of Matlab available on DesignSafe. The first one that we just call Matlab runs an interactive Matlab 2016 on a virtual machine. And the advantage is that you can work directly on your file rather than copying them to and from Stampede. So it's very handy to use. And the good thing is that it starts, the connection to the virtual machine starts very soon, so you don't need to wait since it is a virtual machine. This is the main difference with the other application that we have available, that is Matlab 2017. This one is also an interactive section, but it runs on Stampede 2. This means that for accessing it, for actually using this application, you need to wait for the queue, and so wait that is the turn of your job, so it may take some time. So we suggest for standard post-processing analysis, if you're not dealing with very enormous data, you can just use Matlab, the standard Matlab version available on the virtual machine. So how to launch an analysis using OpenSees? The tab is already very similar to that. From the data processing, you select the Matlab tab, and you just need to pick the the desktop resolution and the duration of the job and the job name, and then you need to run. As you can see here, in this case, you don't need to input the directory, just because you can go through the directory once you are in Matlab. Once you submit the job, you will have this, in a few minutes, you will be able to connect to your virtual machine. And once it's ready, that's what you will see on your screen. Basically, you will have access to the virtual machine with an interactive Matlab that will work exactly like your Matlab on your computer. What you can see here that I was mentioning, that basically you can go through all your data and just pick the folder that you want for the analysis. In particular, we will provide also the post-processing files for the two OpenSees examples that we were running on the same folder in the community data, and there will be the file post-processing Matlab for the OpenSees EXPRESS analysis that will plot exactly the same outputs that we were looking at before in Jupyter. And then we have something very similar, of course, also for the parallel version of it, and that will plot similar results again. After that, before the last step that we would like to cover, the last thing that we would like to cover before closing is what are the alternatives available on DesignSafe to launch OpenSees. Because this is what you can do directly using the portal, but you have also alternative ways. First of all, you can take advantage of the powerful tool that is Jupyter Notebook, and you can do it opening a terminal or using Agave API, and I will go through both of them in just a few seconds. Or the other alternative is to use the command line interface that also Charlie was mentioning before. So let's start with Jupyter Notebook, how to open a terminal. Of course, this is from the main page of Jupyter. Once you launch the application, you just need from the right side to pick a new terminal. And once you have it, basically you have a terminal available. Something very important is that you can just go through your file, changing the directory, because this will be basically will open the terminal in the directory where you were at, but you can navigate through it. Once you are in the folder with all your input data that you want to launch and the job that you want to submit, you just need to type OpenSees, and you will see the standard OpenSees window that you are used to. At this point, you can just run interactively this Matlab application, OpenSees script. And something very important that I want again to underline is that this analysis, this interpreter, allows running interactively on a virtual machine, and so is available only the sequential interpreter of OpenSees. The other alternative is to use Agave PI, and this is very useful because you can create a workflow and so have included in your single script also some post-processing tools. Actually, there is already some material about that you can find still always in the community data. This is the link, and this is something that the group of Professor Pedro Arduino from University of Washington published on DesignSafe. And if you click on that, basically you can see how this script looks like, and basically how to say there are some information on how to set up Agave to start OpenSees job, and then some details about the post-processing capabilities of Jupyter. If you want to know more about that, or if you want to more information about how to launch in general numerical simulation using Jupyter, you can watch the tutorial available on the DesignSafe webpage that will explain you how to do this. The last alternative that you have is to use the command line interface. This is something a bit more advanced, because in this case you are accessing directly Stampede 2 using a secure shell using the terminal of your computer. Something that we have to say, that basically in this case you need to apply for allocation attack. So it's not enough just having an account to DesignSafe on DesignSafe to access Stampede 2, but you need to ask and to apply for additional allocation. At this link there are all the information about the allocations and how to request it, and how many resources you can have, and how to increase the number of allocation. But the most important thing is that you need that before running an analysis using the command line. Once you have access to the shell, secure shell, you just need to use you can use your terminal to access directly the Stampede 2 supercomputer. And you will have basically, once you input your information and everything, you will be able to see directly the windows and access and work directly to that. At this point, to submit a job, you just need to submit a batch script, and the batch script is basically a file that we are calling here my job script, that contains all the information necessary to run your analysis. In particular, here there is an example of how it looks like. As you can see here, there are a bunch of information about the name that you want to use, the type, the queue that you want to use, and basically you are using a normal queue if you want to use a Stampede 2, but you have access also to the other resources available at TACC. And then you have to define what is the total number of nodes and the total number of cores processors that you want to use. This is something very different from what you have through the portal, because through the portal you can only ask for the number of nodes from 1 up to 12, and you will get automatically the maximum cores available for each node, that is 64. While here you can pick also a higher number of nodes and less number of processors. Of course, you need information about what is the runtime of your analysis, and some personal information about the email for notifying the beginning and end of the jobs. And here in this last line, there is basically the name of the allocation. That is something that you get once you have the permission to access, to stamp it to the secure shell. At this point, those two last lines are basically the lines that will allow us to run OpenSees jobs directly on Stampede. You have basically to load what is the module that you need, and this is what you need for OpenSees. And with this command, you will actually run your analysis. As you can see here, we are calling one application, in this case, OpenSees MP, and we will just tell the name of the main file that we want to run, the main TACC script. So similar to what we did before. That's important is what is the path that we are using here, what is the directory. In particular, with this directory, you will have access to OpenSees MP version 3. But if we want to use a different application, here there are the links for accessing OpenSees MP or SP version 2.5 or OpenSees SP version 3. This was my, oh, sorry, if you want a complete guide of the how to access the secure shell and what you have to do to apply and to ask for allocation, there is a full guide available at this website. So with that, now this was my last slide. I will be happy to take any question.
Does anyone have any questions for Margot regarding OpenSees and DesignSafe, maybe using Agave Pi with OpenSees, how exactly it works? So I did see a couple questions talk about the infrastructure and asking us about how Agave Pi works. I was going to answer that kind of in a broad fashion. So DesignSafe is a portal that's sitting in front of our HPC resources, all right? So what that means is anytime you execute a job through DesignSafe, whether that be a job like OpenSees or Matlab or Jupyter Notebooks or something like that, as well as copying files or moving files or sharing files with other people, what you are doing is you are queuing up a job. You're asking a job to be put into a queue for our resources to handle. Those jobs are handled or go through Agave and then get executed on our main systems. So there is a delay in starting up a job, getting it to the server, for getting it to the node, for the node to then execute that job and then give you output. Once you have that output, now you can do your data analysis, you can modify your job and start your cycle again. This is essentially how we can give you a powerful machine like Stampede 2 and be able to utilize that using a front-end environment like DesignSafe. So I hope that answers some of those questions on exactly how DesignSafe works on an infrastructure level. So thank you very much, Margot. That was very, very useful information. I really appreciate your time.
Oh, thank you for having me here.
Right. So the way we usually handle these is we'll take a few more questions. When the questions are over, what we can do is we can then take the discussion to DesignSafe. So if you go to DesignSafe or over to Slack, if you go to DesignSafe-CI.slack.com, there's a general station channel. There's also a training channel, and you can ask us questions there, and we'll see if we can do a little bit more digging or some more one-on-one time. But once again, thank you very much, everyone, for coming. We are just after the 2 o'clock hour here in the Central Time Zone. I hope you guys have a great weekend, and we'll see you next time. Thank you very much.